how to take this really awesome distributed system of Kubernetes, and how can you start to take all the infrastructure that it takes to run something like a TensorFlow cluster.
Hello everybody and welcome to this edition of the Ampere Developer Impact. And I'm delighted to be joined today by Chase Christensen. A little bit later we'll be talking to my colleague Jeffrey too about some of the work that he's been doing with the project. But first, Chase, welcome. Thank you for joining me.
Yeah, awesome. Really excited to be here.
The reason we're talking to you today is because there's been some developments in recent times around Arm64 for Kubeflow. You are one of the maintainers. What exactly is your title with the Kubeflow project? And can you describe the project to us pretty briefly, please?
I'm part of the Kubeflow Steering Committee on the project, which means I was elected by the community to help kind of make sure that the community is aligned to the goals of the greater ML community, as well as work closely with like the CNCF and make sure we're all aligned. When you think of Kubeflow, literally in the name, we have Kubernetes, right, which is like the AI, the infrastructure world of the house, and Flow, which is the AI side of the house, so the ML side of the house. So bridging those two worlds ever since its early inception has been the mission of Kubeflow, to build these two communities together.
Right, and the flow comes from TensorFlow originally, right? Wasn't it the Kubernetes TensorFlow operator was kind of the origin story?
Part of it, and then, there's this like, deep lore for Kubeflow. Sometimes it's TensorFlow. Otherwise, people will say, well, it's the flow of data across Kubernetes. And so TensorFlow was part of that tooling. But now, of course, we support more than just TensorFlow.
Okay, so Kubeflow is fundamental to running AI workloads on Kubernetes. Can you describe roughly like how the project came about, the evolution to where it is now, and how it fits into the general AI ecosystem? Like people, I'm sure, are aware of things like PyTorch and SciPy, NumPy as frameworks. They're aware of large language models are very popular and getting a lot of attention in Gen AI right now. But how does Kubeflow fit into the whole end-to-end ecosystem?
Yeah, so early on in the inception of Kubeflow is how to take this really awesome distributed system of Kubernetes, and how can you start to take all the infrastructure that it takes to run something like a TensorFlow cluster, as well as notebooks, all these different tools you need to do that model development lifecycle, all the way from problem definition to model serving, right? We have that like famous infinity sign you see for the DevOps loop. Well, turns out that there's also an MLOps loop, right? And then now that was the birth of, we had the DevOps engineer, which was how can we get developer and operations, build automation for them to work nicely together? Well, part of what Kubeflow was building was, hey, how can we build the tools in an integrated fashion or an ecosystem of tools where now we can also bring these machine learning engineers. So part of the greater ecosystem is working well with Kubernetes and being able to pick these projects to deploy these systems wherever you need them, as close to your data as possible.
And I know we've had this conversation in the past about how, MLOps is mostly the ops part. There's a lot of data ingestion, data management, log management, and all of the storage, all of the stuff that comes along with machine learning. The role that Kubernetes plays is plugging all of that kind of stuff around the model into your actual model training and model inferencing. Yeah,
so think of Kubernetes as the engine, and Kubeflow is the car. So a lot of the ability to, and we'll show it today, like deploy a manifest to serve a model. So pull a model like you would pull a container and serve it. We're going to empower you with the APIs at a Kubeflow level, but then underneath the hood, we're unlocking the power of Kubernetes to do all the things you want, right? Drift the controllers with Drift, the declarative APIs. That API we want to leverage for these ML workloads to make them more beneficial for your teams.
And can you give me a little bit of insight into the importance of Arm64 in the Kubeflow ecosystem?
So even from the early days, like the rallying cry of Kubeflow was portability, scalability, and composability. Now, I think sometimes we'll say sovereignty, right? And that you want to make sure that we can fit how you want to deploy your infrastructure. And that means being able to deploy wherever you want Kubeflow, whether that be an on-prem, which we hear a lot about. Hey, I want to do an edge device, and I want to have the flexibility to choose the infrastructure for my edge device. We want to do the same thing that Kubernetes does, which is bring those APIs, but also bring those machine learning tools. So when it came to ARM support, we heard a huge rallying cry within the community, which was, we want to support ARM. We have ARM devices we want to use for Kubeflow. How can I integrate with Kubeflow? And so that was part of why we saw Jeffrey come in, and Jeffrey's been really helping support build these tools, because there's a huge demand in the community to be able to deploy Kubeflow where they need it.
And what kind of things are people doing on ARM devices in the Kubeflow community?
Yeah, today we see a lot of data preparation. We have the Spark operator. There are folks looking at things like that, as well as serving models. Kubeflow Pipelines is the big one that folks are really interested in. The actually early request for this was I was at a KubeCon, one of London, I believe, and someone was saying I want to do video processing on the edge, and they're asking for more support for ARM. So I think that's where a lot of this is going to go, and that's a lot of the interest we see in the community.
Now might be a good time to bring Jeffrey on the screen and ask him about some of the work that he's been doing with Kubeflow. Jeffrey, too, thank you for joining me. So, Jeffrey, can you describe briefly what exactly have you been doing in the Kubeflow community, and why has it been so important?
Yeah, thank you. So usually we started from the investigation, try to see which one's broken and how to working on Arm64 platform. So we found out the Docker file didn't support the multi-architecture support. So we fixed that by adding the target argument. So the argument is adding, so everything tests fantastic. So we push the PR, I believe it's 12313. So that one PR merge, and everything can be built as supporting Arm64 without problem. But afterwards, you still don't have the container image on the GitHub container registry. So we talked to multiple community members, say, hey, why do you work on the workflow on the GitHub? So I started to work on the automation for CI/CD pipeline to make it multi-architecture image building supporting. So for example, we started to find out how can we using GitHub Runner, or you can using the external hosting the virtual machine on Oracle Cloud to running our Ampere A1 instance or A2 instance. So they can build with the Docker build-X. And after that, I found out the community asked me to say, what do you use in the native runner on GitHub? And so that one have a Windows-2404-ARM. So that one works. So we're starting to do the Tango way. So 2-step. First step is building the containers for each native platform on 2 different runners. Afterwards, we're using the other runner to bring out to support create manifest. So pulling those 2 image digestions or push out. So that one is making it happen.
Okay. Chase, can I ask you a question, follow up from what Jeffrey just said? Is he talked about multiple Docker files and multiple containers that are built in the Kubeflow project. Can you give an overview of the architecture of Kubeflow and the different projects that are in there and the roles that each plays?
So this is something that's really interesting when we think about Kubeflow, and actually we kind of call it out here. Kubeflow itself is an ecosystem of tools that we also integrate into a distribution or a platform itself. So Kubeflow, often you hear the Kubeflow platform, but it's also an ability to take these different projects within Kubeflow and actually bring them together. So you can actually deploy individual projects if you want. So part of what Jeffrey is saying when we want to say we want to cover the entire Kubeflow ecosystem or Kubeflow platform, this is really what he means. And this is tackling the entire machine learning development lifecycle when it comes to actually running this on Kubernetes. And I would like to notice Kubeflow is in the middle there, but up top is really the things we want to be in service of, whether the models you're pulling from Hugging Face, making sure that you can operationalize PyTorch, interfacing your system with notebooks, using the Kubeflow SDK to launch these things. All of these things are here to make sure that you can smoothly do things like this Gen AI lifecycle. And this is a giant kind of architecture flow, but when it comes to being able to prepare the data, all of these different tools, prepare the data, interface with the data through notebooks, train and scale that data, fine tune it, hyperparameter tuning, serving, as well as things like we actually have a model registry and pipelines within the project. This is really the goal of Kubeflow. And these are the projects that we do, that we support to enable that.
How many containers are there in the Kubeflow family?
It's quite a few. So this is definitely massive coverage we're looking for.
It's dozens of containers, right?
Right.
Maybe
Absolutely.
30, 35, something like that.
Right.
So, Jeffrey, how many of those containers now have multi-arch builds supporting ARM64?
So if I correctly scanning on the Kubeflow version 1.11, so that one have a totally 85 container image across different components, probably 18 of them for KP, 50 and 60 for Kserve, for Kubeflow pipeline, probably about 15. I'm working on those, especially on Kubeflow pipeline. Original 15 is only support x86 platform. So now I convert 13 of them become support.
today what we're going to show you is actually going to give you a tour of the Kubeflow dashboard itself. So this is a lot of people's first introduction to Kubeflow. We have this Kubeflow dashboard. This is going to be like, think of mission control when it comes to all the things that are important for a machine learning engineer or a data scientist. But this is something the platform team would be providing to the machine learning and data science teams. And from here, you can see your different notebooks you have. If you had tensor boards created, you can see your volumes that you've actually provisioned, the types of access modes. So if you want to share data sets, you can see as I was building the demo, I was spinning up a bunch of volumes. But you could share data sets, download them, attach them to different notebooks. We'll show you how. Katib is actually like auto machine learning or hyperparameter tuning. You can create experiments and present them to the cluster from Katib. We have our different pipelines. You can create pipelines through here. This is a fresh cluster we just spun up for this event, so we don't necessarily have a ton of pipelines, but these will be your pipeline artifacts that you'll be able to track, as well as executions and previous runs. So this is going to be like your first introduction, kind of first portal into the system. What's also cool to call out here is this is namespaced, so I'm only seeing things that are dedicated to Chase, right? So this is amazing because I can launch training jobs in this in my own namespace. When you actually want to create a notebook, talking about things that we can scale up and down, you actually, from here, we could create a Jupyter notebook. We could name this whatever we wanted. We could call this new ARM notebook. From here, we actually can, and this is cool, you can present to your teams. So say, in the data science world, reproducibility and replicability are really important. Can I get the exact same libraries running on the exact same data to develop my models and serve them, right? So giving you these standardized APIs and the ability to do that is really important, to the point where I could then here, this is actually a Docker container image that I built and I pushed to my registry, but then I'm presenting this to my data scientist. If there's a data science person looking at this, they could say, oh, here's the cluster I need to reproduce this experiment. I'm going to use this, and this could be a hardened image that's actually going to then spin up this notebook instance. You can decide the amount of CPU, the memory constraints. If we have a GPU in the cluster, you could pull a GPU. Maybe you don't need it. You're using a lot of really CPU efficient libraries. And this is going to handle the actual scheduling and all the stuff we're talking about from an infrastructure standpoint of getting the volumes, right? Scheduling the networking paths, making sure it's exposed. All of that is going to be handled by Kubeflow, even to the point of if we wanted to attach an existing data volume, maybe you have a data set you've already downloaded. You don't want duplicates of shadow data. You can actually attach a data volume to this. You could add or request a new volume, determine what types of classes, you have stored classes within your cluster, as well as there are actually configurations that we can attach. So these are configurations that it's actually going to mutate the manifest for you. But if I want to attach, maybe I have a secret that's going to have my Kaggle credentials in there that I don't want to have people hard coding live, or a service account token. They can click these configurations and it will apply those configurations to the actual notebook itself, right? And then once we have all these things configured, you'll be able to launch a new notebook. And I'm running through this. This is just a Jupyter notebook. We download the data set. We do some exploratory analysis. These are actually going to be, it's going to try to classify street signs here. And this is like a classic data problem. You can quickly grab all the classes. We can actually deploy and build the model, look at the nature of the data within the model, train the model, right? You can see all my epochs for the training, visualize the model, see what the loss accuracy, as well as create an inference pipeline locally. So again, this is all like no GPUs is on ARM. I can create a local instance here, and I can run a prediction. It's going to tell me how confident it is this is general caution. I don't think this is general caution. I think I need to do better with my test validation data. But then you can actually then start to say, okay, how does this look like going from a development to maybe a multi-tenant environment, right? This is great because it's on my notebook. But what if I wanted someone else to hit this service? Well, you could actually save this model. We have this S3 on Kubeflow. It's called Seaweed-FS. I can actually save this model locally, and then I could, with the packages I provided, save it to Seaweed-FS. So this is my serialized model in a bucket. I can create the inference service. This is actually just going to be, if we look at the source of this model itself, this is going to be a manifest that I'm going to deploy. Here's my secret with all my information. Here's the service account. I'm then going to serve this model, create my inference service, and this will help, we can share this code out. This will actually create the manifest for you. And then apply a policy to make sure that Istio, under the hood, we have Istio that can actually access this. But if I hit this, I'm actually hitting a shared model. This is a served model that I can get more details on.
So for those unfamiliar, and I don't know if there are people who are unfamiliar with Jupyter Notebook at this point, but outside of the ML world, my understanding of it, and it's very high level and probably wrong, is that Jupyter Notebook is kind of part documentation, like you're creating documentation for things, but also part execution engine. You can embed source code in there and execute it and run it live and see the results. Is that right?
Yeah.
Is my description of it accurate for a start?
Yeah, absolutely. And I think even early on, so we have a project within Kubeflow called Kale. And Kale's really interesting because Kale says, if you look at a Jupyter Notebook, it's a pipeline. Like what I just ran through is a pipeline. So you could use something like Kale to take these different cells and say, what would this look like as a container or something I could actually deploy on a multi-tenant environment or scale up? Again, mapping that from development all the way to production, even to the point we serve this model. That's part of where Jupyter Notebooks fits in when it comes to Kubeflow.
So the way when you start a notebook, what does that actually do in the back end? Is that starting a collection of containers or? Yeah,
absolutely. It's actually, we have a custom notebook controller, and Notebook V2 is coming out as well, which is going to be even, there's a lot of really interesting features coming out. So definitely keep an eye out for that. It's actually creating a notebook custom resource definition that's going to attach all the things you need to serve this notebook application. So you could actually go push a notebook CRD to Argo, and it will create a notebook for you within an environment.
Okay. That's kind of wild. And Notebook V2, I believe I've had this conversation with Jeffrey, will have much better support for Arm64 than Notebook V1. Is that correct?
Yeah, absolutely. There's a lot coming in V2, improving the user experience for Kubeflow. So definitely that's going to be really exciting, especially with the ARM support.
What's next for Arm64 support, Jeffrey? When should people expect to see all of Kubeflow containers be multi-arch manifests at this point? I know there are some end users who are interested in running Kubeflow on Arm64. How should they get engaged to try things out and maybe help give feedback on how things are going?
Yeah, so give you some kind of big information what we're running for. So we have a Google Summer of Code 2026 initiative. They recently accept our project code end-to-end Arm64 support and validation on Kubeflow. So that one will have a college student starting to work on validation on Arm64 for Kubeflow. And we are going to make sure Arm64 become first-class citizen on Kubeflow environment and all kind of components. And also can run full Kubeflow end-to-end test suite and on infrastructure for all the validation. Okay. So that's the kind of goal we want to achieve.
You can get more information about which Google Summer of Code projects have been accepted for the Kubeflow project. How many do you have? You usually have more than one, right?
When it comes to projects just in general for GSoC, there's, I believe, yes. I think it gets up to 13, I believe, different types of projects for Kubeflow that we're proposing. Wow.
And how do people apply to this one to do the Arm64 validation?
It should be through the link there. You can actually select what projects you want to directly apply for, and then you'll be able to submit a proposal, which is kind of just how you're thinking about the problem. And then the maintainer, which is actually Jeffrey's going to be the mentor for that project, will reach out to you and help you get started. It's awesome that we're seeing interest, folks that want to run Kubeflow for ARM. As I said, Kubeflow is there's a lot of different projects. So whether you're thinking about training things on ARM, serving things on ARM, notebooks on ARM, you can find me on the CNCF Slack. My handle's Chase Cadet. I'll help you point you to the right maintainer, as well as just get involved, because we are always looking for end users that are leveraging these tools. We're always looking to improve them.
Thank you very much for joining me, Jeffrey and Chase, to talk about Kubeflow on Arm64 and the contributions that Ampere has been making to the Kubeflow project in recent times.
Thank you for having me.
And thank you everybody for watching this episode of the Ampere Developer Impact. And I'll see you again soon. Goodbye.